Okay, thank you. So welcome everyone. This is going to be a presentation that I call Reclaim the Stack. It's a story about how a medium-sized software as a service business migrated from a fully managed platform as a service to an in-house Kubernetes platform built on Talos Linux. Quick note about me. So my name is David. I've been making websites since 1995. I was 12 years old at the time and working full stack with Ruby on Rails since 2007. Last 8 years, I've been working at my news desk, where I'm currently the DevOps lead. Though I would like to emphasize that I'm really just a Rails developer. So I think of DevOps as I understood it to be the original meaning of the word, which is a developer doing ops. So that's me. And I'm also Debuggkeys on Twitter, if you want to follow me there. The agenda here is what is my news desk and motivations for an in-house platform, the proof of concept phase, the viability study phase, platform components, the developer experience of using the platform, and some next steps. But first, I would like to dedicate this presentation to my guru, Srimati Nirmal Devi, because today is her 100th anniversary. So she's in my attention, and the meditation that she taught me has been just so instrumental in every dimension of life, including even programming, where it's nice to keep a cool head when you're doing problem solving. So with that said, let me tell you something about my news desk. My news desk is positioned as a one-stop solution for PR and communication. So you can imagine things like content creation, press release, and news creation. Now, of course, GD, like AI supported, and content distribution, published in newsrooms, email journalists, share on social media, analytics, like who is reading your content and how are you doing compared to competitors, media monitoring, what people are writing about your brand and who are your influencers, things like that. In numbers, we're about 150 employees, out of which we have about 20 developers, about 5,000 customers, 80,000 communicators, which include journalists and other user accounts. We publish about 11,000 stories per month, send about 5 million emails, and get about 6 million page views to our newsrooms. And I should say that this is real page views, not the bots, which are actually like 90% of the traffic these days. So this is to say we're a medium-sized company, both in like the organization and also in kind of deployment scale. Technically speaking, we're running a monolithic Ruby on Rails application. We have a React and GraphQL-based publishing tool, a few ancillary Ruby and Node.js services. In terms of databases, we're mainly using Postgres, but also Redis, Elasticsearch, and Memcache. And until 2 weeks ago, we were hosted on Heroku, which is to say we outsourced most of the DevOps to their platform. So motivations then. So actually the main motivation here is the GDPR regulations within the EU, which if you have a light interpretation of that, it means that data should be stored within the EU. But the stricter interpretation is that data cannot be shared with any non-EU company, which includes then all the major cloud providers and Heroku, etc. And we also found that Heroku was stagnating quite a bit after being acquired by Salesforce some years ago, and also having an increasing number of security and stability issues. And finally, cost, which maybe wasn't the main motivation, but it was certainly a big enabler in spending time and resources in doing our own platform. Alternatives we looked at was, the first thing that came to mind was looking for some kind of Heroku clone within the EU. And we found a few, but we also found that they had some mixed user experience, and also there's the trust issue. Like these are mostly startups and they don't have a long track record of delivering a stable service, so we weren't sure whether we should trust them. So then there was the idea of do-it-yourself Kubernetes. And the idea triggered within me via a Finnish Rails developer called Vito Botta, who wrote a CLI tool for running Kubernetes on Hetzner Cloud. So, and I also found that Vito was working for, fairly small or medium-sized company. So then I thought maybe Kubernetes is viable for small to medium-sized companies. I thought maybe it's more of an enterprise thing. Was my kind of feeling before this. And also I found out that Hessner had like shockingly good priced. So then the hypothesis was that the pros here was that Kubernetes was trending to become the de facto deployment platform. And also that there would be open source operators available for managing highly available databases. And this was very, very important for us because we don't have a lot of expertise at this level. So having good software to manage the databases for us was crucial. And then the freedom part, like being hosting agnostic. And this is really what Reclaim the Stack is about. It's about breaking free from, feeling like some hostage at these cloud providers and being able to kind of do your own thing. And to achieve a stronger end game, to be able to customize and optimize things to our needs. The cons would be having a steep learning curve, having to build tooling in-house, platform engineering, and also a lot of unknown unknowns. Like we have literally zero previous experience with Kubernetes at this point. So now we're in late August here, and I'm having these thoughts to myself, and I'm thinking like, hey, it would be cool to try, but I really don't feel like doing this by myself. So I knew that I had a colleague who was a bit into Kubernetes, or he thought it was like interesting technology. So I reached out to him, and he was like, yeah, let's do it. And that's when I decided to do a little proof of concept of my own. And I did this during our lab days. So at my news desk, we have lab days, which I think of as do whatever you feel like doing for 5 days per quarter. It's not quite the official description, but that's how I think about it. And on these lab days, I thought, hey, I want to try this Kubernetes stuff. So this is around the same time that Heroku announced that they were going to remove the free tier of their hosting, where I had some hobby applications. So I thought, why don't I try to host my own hobby applications at home? So I found this secondhand Intel NUC and purchased that, and I went on trying out Kubernetes. So this is early September, week 1, installing Ubuntu and trying out K3s, which is like a minimal Kubernetes distribution. Figured out how to make a decent Docker file for Rails applications. I deployed Postgres via the crunchy Postgres operator and deployed this hobby project, rogtime.com, and exposed it via a Cloudflare tunnel. And then deployed Prometheus Grafana-based metric stack, as well as low-key-based log aggregation, and figured out how to do automated GitOps-based deployment using GitHub Actions and Argo CD. So quite a lot done in this first week. So, we got this kind of feeling. But then we need to get serious. So we needed to actually check that we could do this with our real application, not just a hobby one. So after getting kind of the green light from our CTO, who said like, hey, this sounds like fun. And then off we went, me and Fredrik, my colleague. So week 2 to 5, can we run my news desk? So this is where we selected Talos Linux as the operating system. We bootstrapped Kubernetes cluster on Hetzner Cloud, and we deployed the metrics and log aggregation. We tested 8 different database operators. We made an optimized multi-platform Docker image for my news desk, and then kind of found out the hard way that ARM support wasn't quite there yet for a lot of the things that we wanted to do. So we decided to just go with AMD 64. And we struggled with Argo CD, the GitOps tool, a few times per day, which is related to our lack of knowledge with Kubernetes in general. So we would keep pushing things that didn't quite work or didn't resolve or didn't manage to boot, etc., and trying to figure things out. We imported the production database a few times over using all these different database operators because the goal here was to replicate our production environment in the cluster and do some testing on that. We researched 8 different persistent storage solutions and settled on one. We got my news desk running sort of, but the performance was awkward because we were at this point using the shared cloud nodes. So then we decided to just order a bunch of AMD servers and migrated to bare metal. And now we're at week 6 running on bare metal. And now we will sort of pitch Heroku against Hetzner here, see what we can find out. On Heroku, we're using 8 of their performance L dynos, which is their biggest kind of server type. They come with 4 dedicated CPU cores each. And we're also having quite the beefy Heroku Postgres and also beefy versions of our other databases. On Hetzner, we have 2 AX101 servers for web and 2 for databases. So this model is running the Ryzen 5950X CPU, comes with 128 gigabytes of RAM and a whole bunch of NVMe storage. First thing we checked was latency, using just a single connection to see latency. And we used one of our sort of popular endpoints, our Swedish newsroom. And we could immediately see that we were getting like way better latency on Hetzner here, 205 milliseconds average versus 134. And in particular, this came out of the 90th percentiles and the 99th percentiles being just massively better on the bare metal servers. Next, throughput, we used the same endpoint, but with 64 concurrent connections. Here we could reach 163 requests per second on Heroku versus 261 on Hetzner. Again, much better latency figures, but in particular, the 19th and 99th percentiles, it's a huge difference. We also did a sustained load test, and here we recorded 7 days of GET requests from our real production logs. And we used 96 concurrent connections, and we left it like replaying the log overnight. The results were 28,000 requests per minute, which is about 460 requests per second. And this is like more than 10 times our peak production load. So this made us feel very, very confident. And the kind of final nail in the coffin here, the cost comparison, we have Heroku at $7,650 per month versus $520 per month for this particular Hetzner setup. So that's like a 15x difference right there.
That's amazing.
That's amazing. And yeah, we were feeling really good at this point. It seems really viable. So off we went. So now we're going to just touch on like choosing the hosting provider and operating system. Hosting provider, like Hetzner, is very, very simple. Price performance is just really great here. And can we back it up? Yes, we can. We went full Pepe mode, and we made this crazy spreadsheet where we tried to kind of price versus performance, normalize different providers by just synthetic benchmarks. But we have the price performance thing here. So just to give an example, like Heroku here at 91 euro per performance, and the node that we ended up with in our cluster is at 2.37. So huge difference. To give an example of something that maybe more people can relate to, we have these AWS instances here, like the latest AMD one at 20. So it's also like an order of magnitude cheaper than the on-demand pricing you get at AWS. The operating system then, we're at TalosCon. Let's talk about Talos. So the pros here, it runs Kubernetes. That's exactly what we wanted to do. And but maybe more interestingly, perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. And I was very, very impressed when I read some of the early Talos blog posts describing like how Talos was conceived, and how it was basically like this painstaking process of like adding tiny things until it ran. And it was literally like there was nothing left to take away, was kind of the feeling from reading that blog post, and it was very inspiring. So like no dependencies or package upgrades to worry about. I was kind of imagining otherwise having some Ubuntu machine, and you would SSH in there, and you would have, your 150 packages to upgrade, and you wouldn't know what they are and what will happen when you upgrade them, etc. So we were looking for something that would kind of get out of our way, basically, and so we can focus on the Kubernetes part. We also found that there was an exceptional community Slack. We were so happy to get so much help during these months from people in that Slack. And also just how the configuration management could work, like having a YAML file, which then could make it declarative, patchable, and stageable. And zero headache Kubernetes upgrades was also fantastic. The cons then, it's another learning curve. Like no shell felt so strange after being used to like normal Linux from before. So it took some getting used to. It's also early days, not that widely adopted, but to be honest, like as kind of an early adopter of Rails, this is something that gets me excited, not the other way around. So I'm happy to bet on kind of technology that just seems really great, even if it's early days. It may not support all use cases. So for example, if we had S-RAID support, we would probably use that because Hetzner servers come with double disks, and we don't really know what to do with all that disk. So, but it's not a major deal for us. The bootstrapping on Hetzner was quite painful and required a lot of sort of trial and error. But eventually we found out about this bad boy. So that once we learned how to kind of set up our grub config to point to like our own service for configuration, that enabled us to actually take the next step. And we actually made a kind of our own web app that we use to define clusters and like configure them. So we can like from that, we order a server at Hetzner, like it will pop up here through like their API, and then we can bootstrap it through their, it starts with their rescue mode OS, and then we can just SSH in there and put our Talos image on there and get it configured. So I will emphasize that this is not trying to become like Omni. it's very limited, but it does get us like from 0 to having Talos running.
So this is effectively a provisioning system that works on Hetzner to deploy Talos clusters.
Yeah, exactly.
Yeah.
So it's very Hetzner specific.
And I assume it's written in Ruby on Rails.
That's correct. Yes. I think over 3 days or something.
Nice.
So then platform components, then we chose Argo CD for the resource management to GitOps all the things. For network interface, we went with Flannel, which is just a default, and we like defaults, although we have had some minor things which make Flannel a bit annoying. So if we did it all over again, maybe we would have used Calico or something else, but it's not a big deal. So we'll just keep using Flannel. Container registry, we use Google Artifact Registry because self-hosting seemed a bit too risky. And also this was just cheaper, had a better pricing model than the alternatives. Also, the data center is in Finland, which is also where our servers are located. For storage class, we went with the OpenEBS Dynamic Local PV Provisioner, keeping in mind that our persistent volume use cases are databases only, which means that we can achieve durability and high availability using database level replication. And we found that this was very easy to reason about, and there wasn't any performance overhead, and it was just a bit too much of a jungle, like going into network storage at this point. It's something that we might look at later on. Secret management, we went with Bitnami sealed secrets, which means that we store the secrets directly in the GitOps repository, but in an encrypted format. This was also easy to comprehend and didn't require any external services to run. For ingress, we use Cloudflare D. So this is encrypted tunnels between Kubernetes and Cloudflare. This means we don't have to open any ports or deal with load balancer resources, which makes it super easy to use in bare metal and home environments. The con here is you have to marry Cloudflare, but since we were already married to them, that made this kind of an easy choice. Service mesh, we're doing Linkerd. This helped us with in-cluster load balancing between services. It also provided a real-time observability dashboard, which was really nice. Monitoring, we went with Prometheus Stack. It's like Grafana-based. Probably most people know about this one already. It's like a de facto standard in Kubernetes. And for log aggregation, we went with Grafana Loki. Now the operators, the Postgres one, we chose the Crunchy Postgres operator, or PGO. We found that it was very robust in our testing, and a really cool thing here is that it uses PG backrest for super fast backup and restore. We're talking like 10 times or faster than doing a regular PG dump and PG restore. Con is they don't really offer any community support. There is no Slack, nothing like that. So you have to kind of trust it. You can't really talk to anyone, but it's been solid for us. Though I would like to actually plug also the cloud native Postgres operator. They were also really impressive. and they had a really good community going. But we did have some bugs as well. And once we kind of had this PG backrest experience, it was hard to imagine doing anything else. For Redis, we use the spot-at-home Redis operator. This is actually the only open source Redis operator which supports high availability via Sentinel. So in Redis, you have these two ways of doing high availability, either Sentinel or cluster mode. But the cluster mode is way more complicated than what we need, and it also wouldn't be compatible with all the things we're doing. So we had to go with Sentinel. For Elasticsearch, operator was a simple choice. Elastic Cloud Kubernetes. This is the official operator from the Elasticsearch team, and it's worked really good for us. So now let's look at the developer experience of actually using this platform. The principles for us to design the developer experience was that we wanted to hide Kubernetes from the developers. It doesn't mean that they don't have access if they want to, but we didn't want any developer to have to learn about Kubernetes and all the YAML and all the stuff. So we wanted it to feel kind of like using Heroku. So we needed to ensure the tooling was in place for all the day-to-day tasks and make it as good or better than Heroku was the goal. For this, the main way that the developers interface with the platform is a CLI tool. We call it K. It's for Kubernetes or OK, and it's short to type. And some examples of what we can do with that. So it's a single file Ruby script, 0 dependencies. It wraps kubectl and interfaces with the GitOps repo. And it does all the things we used to do with Heroku. So for example, configuration management. We follow the 12-factor app approach, which I guess was sort of founded by Heroku. So everything is environment variables. We can run kconfig and the name of the app, and we get the list of environment variables for that app. But secrets can be shared. So this is a bit different from Heroku. So we can kind of dry up the secrets management a bit by doing that. And we can go ksecrets edit to edit the secrets, and that just opens up the kind of editor configured for the OS. And once you save and close the editor, then we sync that to the GitOps repo. We can tail the logs with klogs, just give it the name of the app, and then the tool figures out like all the Kubernetes resources it needs to follow. We can also filter by type of process or deployment. Log search will open up Grafana Loki interface with a pre-made filter here, so you can start filtering away. And the K dashboard will open up a metrics dashboard for the application. Things like request rate, latency, CPU, and RAM usage. And apart from these kind of metrics, we also have, courtesy of the operators, we have specific ones for Postgres and also for Redis. Another example is krollback, where we could give a list of the 15 latest deploys, and you can roll back if you made like a bad deploy. And in terms of like tooling latency, I find it interesting to highlight like just how much faster we're doing things now. So just running the Heroku CLI tool, it takes like 3 seconds for it to list the commands available. We do it in 100 milliseconds. Running a Rails console, which is like the REPL for Rails applications, would take us 30 seconds to boot at least on Heroku, because it would provision a new EC2 instances and I don't know what. But we can just create a pod and be ready to go in 2 to 5 seconds. Also, like execing into an existing dyno would be 10 seconds on Heroku. We do it in half a second. Deploying, which means on Heroku, like you do a git push and then you get the whole build thing going, would take about 5 minutes. Now we deploy in 10 seconds, and this is because we can just pre-build the Docker images while we run the tests, so they're all ready to go. And then finally, like Heroku's idea of doing 0 downtime deployment is a thing called pre-boot, where it just arbitrarily waits 4 minutes for your app to boot, and then it switches the traffic over. So now we can do it much more intelligently. Just in Kubernetes, we do a roll and restart, and as soon as our readiness probes are good, then we can switch over, which is typically like 10 to 20 seconds. So that's a hugely improved experience right there.
Yeah. For
alerts, we have just the Prometheus stack set up to Slack us in the channel. And all the authentication from the CLI tool to Grafana to all these things is all with Google's single sign-on. So that was also really huge improvement, actually, because all of these tools these days, they seem to get more and more restrictive with like how you sign in. So now you have to sign in like every day or even like every other hour or something, and it's really tedious. So this was a huge improvement. So let's look now at the rollout timeline and some results. So from September here, we're prototyping away, building the stack. In December is where we kind of wiped the experimental clusters and we applied all the learnings to a new clean cluster. And that's when we started deploying our staging applications or staging environments. And in January, we had all the staging environment running, and we also started deploying our first minor production services. In February, we were running all the minor production services, and we also now created a separate staging cluster to try out like OS and Kubernetes and infrastructure changes before applying to production. And in March is the moment of glory when we migrated our main Rails production monolith. This is now 2 weeks ago. So then how did it go? This is the day after, the Monday after we launched. And we have here, like the blue line is the new latency, the yellow line is the previous week. So we can see that on average, we're reducing latency by 33 milliseconds. It's about a 29% reduction. So nice to see after all this work, it just worked, no problems. And cost reduction, we used to pay Heroku about $200,000 per year. The new stack is about 20,000, so it's an order of magnitude savings. And to give an idea of like the scale of the cluster, we have the staging cluster with 7 of the AX41 servers, and the production cluster is running 3 of the AX41s for control plane, and then we have 5 for workers and 5 for databases. So 10 all in all. And this is, to be honest, this is like way more than we actually need, but that's what's actually fun. It is fun now. we have so much overhead that we can just optimize for performance and feel very safe in our stack. Next step and conclusion. So next steps here that we are looking to do is releasing a simple get started quick version of our stack for anyone to experiment with, hopefully runnable via Talos CTL cluster locally. We also want to start a Slack or Discord channel for people interested in reclaiming the stack themselves, and create documentation, screencasts to get people started. And the goal here is to find strength in numbers. So now we're kind of trying out this new path of self-hosting, but we already have quite a few companies in Stockholm who are interested in taking like a similar journey. And so we're hoping to kind of push a community around that. So that also means that if you're watching this and you are interested in cheaper, faster, and better hosting, then maybe you would like to also join us on this journey to reclaim the stack together. And if you are, then you can scan this QR code. We have a little interest kind of submission thing going on there. And also, since this is the 100th anniversary of my guru, if you're interested in trying meditation, I can suggest wemeditate.com. It's all free, and it's been helpful to me. So that's it. Thank you.
That was awesome. That was really good, David. Very impressive. Like, I don't know if you were reading the comments, but people were impressed and excited and impressed with your development team and how you've done it all. That was really good.
Yeah, thanks. Yeah, I wasn't able to see the questions. I was just seeing my presentation.
Yeah. We've still got about 4 minutes before the next session by Nokia. There was a bunch of questions about whether you were aware of, let me scroll back to look at it, Stackrus.io for the DB operator. A few people asked whether you'd evaluated that one.
Yeah, so we looked at, for Postgres, we looked at the cloud native Postgres. We also looked at Stackrus and Zalando, I think is the name, and KubeDB. So we did look at quite a few different ones, though we didn't go very deeply into Stackrus in particular. there is actually another version of this presentation that I did for the Stockholm Ruby meetup last week, which contains, that was like an hour presentation, so I went into a bit more detail. So we will probably share that presentation at some point as well if you join the interest Google form thing.
Yes, and people would like, what is that link to the Google form thing? Because it's gone from the screen.
Right. I guess I should
put that in the chat or something.
Good idea. So here is the link for the Google form.
Great, thank you. Yeah, our developers were excited by the K tool and all sorts of good stuff in this talk. You've done a really good job for people that didn't even know how to spell Kubernetes a year ago.
yeah, half a year ago even. It was interesting. I think like the first 2 months, it was a lot of like at some point I think I was dreaming of YAML, and it was a bit painful. Like Ruby developers tend to be like very sensitive to aesthetics. And, so Kubernetes is not like a very aesthetically pleasing thing to me, to be honest. But it's also like it's tremendously enabling in doing something like this. So we really felt that like, the end game here is really, really strong. And we can build a platform to be aesthetically pleasing for the developers. So.
Yes, yeah, it's nice. There is a question. What storage subsystem did you use for your cluster? So you're running on NVMe on bare metal, right?
Yeah, that's it. So we just use this, the local PV provisioner from OpenEBS, which just means, your persistent volumes is a path on disk. So it made it very, I will say one thing which makes that a bit scary in the context of Talos is that when we do OS upgrades, we have to pass the -- preserve flag. Otherwise we wipe the data. So yes. That's good to know.
Yeah. Well, that was awesome. Okay, so I'm going to leave this session. This session will continue, so people do have the option of staying here and asking David questions via the chat. But otherwise, I'm going to zip over to the Nokia session about scaling a private cloud managed Kubernetes service to over 100,000 ports. But that was awesome, David. Really appreciate it.
Yeah, thanks. So I'm going to just disable my camera and audio here, but I will keep monitoring the chat if there are any questions.